process of aligning a laser can be extremely tedious. If you want to automate the process, technologies are available, but typically they're very expensive. You can spend hundreds and hundreds of pounds getting a system which aligns your laser. We've put together the hardware and software necessary to automate the laser alignment process on a budget. So this is a schematic of how we've set up our system. We have a laser at the bottom left and a defocusing element which we have created ourselves in-house by sanding a piece of clear plastic so that it scatters laser light. And this gives a signal which we can optimize. So typically lasers are a very small area. This allows a kind of differentiable signal that we can optimize onto one of the photodiodes. And we actually have two photodiodes. We have the first photodiode shown in between the two mirrors on the right. This flips in and out. We can flip it in, align to this photodiode, and then once we've aligned to this photodiode, we flip it out and we can align to the second photodiode, which is on the top left of the diagram. Now, the two photodiodes mean that we can align the laser not only in position but in angle. So alignment is achieved using custom code which we've implemented on a Raspberry Pi, written in C and C++. It's designed to take the signal from the photodiode and send pulses to the servo motors to adjust the angle of the mirror to maximize the signal that's on the photodiode. And that's all done through the user interface, where we can see that we've got certain useful features like manual servo control. We've got the ability to flip in the photodiodes and flip in the defocusing element ourselves. We've got the ability to select an alignment algorithm, change the speed and duration for which the servo motors rotate, and we also have a selection panel for which photodiode it is that we are aligning to. So here's an example of a laser alignment procedure. And we start off and we can see that the laser isn't quite centered on the photodiode, and then we flip in the defocusing element and then we click align. Now this is the option you get if you click on gradient ascent on the user interface. The process is the program takes a measurement and then it moves up and takes a measurement. It moves left relative to the initial position, takes a measurement there. It moves right and down and takes another measurement at each location. And then depending on where it found the greatest intensity, it will move to that position and then reiterate over this procedure, gradually working towards the highest intensity being incident on the photodiode. In the eventuality that the initial center measurement is of the greatest intensity, that's when we finish the alignment procedure and we can flip out the defocusing element, flip out the photodiode, and then align to the second photodiode in order to get both angular and positional alignment. So this is an initial scan. This is quite a rough scan. Once alignment is found at this resolution, you can then turn down the duration for which the servo motors spin for, and you can do a finer scan. So let's test. Let's see how well aligned it is after that first rough alignment. We can see that it's pretty much bang on the photodiode, and then we can even turn down this duration of servo pulse and we can go for a finer alignment.